Good day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Tobile Tebe, and this program is proudly brought to you by the Gauteng Department of Education. This is our first lesson of Term 2, grade 8. Welcome back. Let's check our knowledge area. This term will be dealing with matter and materials. And this knowledge area contributes about 33 marks to your final mark. And then our topic is atoms. But we're going to be looking at the subtopic, which is atoms, which are the building blocks of matter, and subatomic particles. Let's check the objectives. Remember, we need to aim at achieving something. What is it that we're going to achieve today, grade 8? We're going to define matter and explain what matter is. And we are also going to describe an atom. And we're also going to explain why atoms differ. Remember, atoms differ. We are going to explain that. And then we're also going to describe subatomic particles and also explain what elements are. And we get all this from the CAPS document, page 40. And then the pre-knowledge. Remember the things that you learned in the past. Remember when you were in grade 7, you did the introduction to the periodic table of elements. This is exactly what we are doing now, grade 8. We are just building on to the foundation that you laid when you're in grade 7. Let's check the periodic table of elements. It is showing us the elements. All the known elements are on the periodic table of elements. And remember, you need to memorize the first 20 elements. You need to know those. All right, good. Let's move on. And then we've got a baseline activity. What I want you to do, grade 8, is to write the baseline activity. It is going to remind you of what you have learned on the introduction to the periodic table of elements. Therefore, I will give you 3 minutes to answer the questions. Step answer. Done writing grade 8? Good. What I want you to do is to take a picture of the work that we have written and send us to 082 760 2630. Take a picture and send us on this number 082 760 2630. Please don't send a voice note. Please don't call. Just text us. All right. Let's check the questions that we have answered. Question number 1 says, what is a periodic table of elements? Then question number 2, what is an element? Question number 3, where are metals, semi-metals, and non-metals found in the periodic table? Let's check our solutions. For question number 1, what is a periodic table of elements? How can you answer that one? How did you answer it, grade 8? Is it? Wow, that's great. The periodic table of elements is a table of all known elements arranged in a what? In a scientific sequence. These are the elements, all the known elements that we have, that we know, they are on the periodic table of elements. Do you get that? Good. Then let's check question number 2. What is an element? What do you think an element is? If we're talking about an element, remember we find these elements on the periodic table of elements, okay? These are the known elements that we have. Do you get it? And then you can answer this question, what is an element, by saying an element is a what? A pure substance which consists of what? It is a pure substance which consists of atoms or one type of particles. Do you get it? An element is a pure substance which consists of only one type of particles, or you can say atoms. All right. And then we call these particles what? We call these particles atoms or even molecules. And then question number 3. Where are metals, semi-metals, and non-metals found in the periodic table of elements? If we're talking about metals, metals are found on the left-hand side of the periodic table of elements. And then the non-metals are found on the right-hand side of the periodic table of elements. And then the semi-metals, they are found in the region in between the what? In between the metals and the non-metals. That's where we find the semi-metals. Do you get it? And then this is our periodic table of elements. If we are talking about them metals, we say we find them in the left-hand side. This is left-hand side. And then non-metals, they are found in the right-hand side. What about the semi-metals? We say the semi-metals, you can find them in the region in between the what? The metals and the non-metals. This is the region that we find the what? The semi-metals. Do you get it? Good. Let's move on. And then with our terminology, we've got a lot of terms that we need to define. Remember, in each and every topic, we come across new terms. Therefore, we need to define them. We need to know what they mean so that we understand better. And then in your examinations, grade 8, you're going to come across the definition of terms. These are the exact terms that will come in your exams. So pay particular attention and make sure you can define them. You are going to be defining the terms from now up to grade 12. Let's check the first one. The first one is matter. How can we define matter? Matter is anything that has got mass and occupies space. So anything is matter. Even the pen that I'm holding is matter. All right. For example, you are sitting in a classroom now. We have said matter is anything that has mass and occupies space. Therefore, the chair that you are sitting on is matter. The table or the desk that you're writing on is matter. The stationery that you have is matter. Okay. Therefore, matter is anything that occupies space and has a mass. All right. And then let's go to the other one, element. This is a material that consists of atoms of one kind. Right, this is an element. Remember the elements, you found the elements in the periodic table of elements. These are the non-elements that we have. They've been arranged in a scientific sequence. Do you get it? And then how do we define an element? We are saying an element is a material that consists of atoms of the same or of only one kind. They are the same. The atoms are the same. That's an element. Okay. And then what about an atom? How can we define an atom? An atom is very tiny, it's very small, it's minute. You cannot see with the naked eye. But how can we define an atom? It is the smallest building block of matter. All right. An atom is the smallest building block of matter. And then we go to the atomic number. When we are looking at the atomic number, remember the periodic table of elements, it has got all the non-elements. And if you take just one box there and check what is written there, you will see the atomic number, you will see the chemical symbol, you will see the name, you will also see the mass. All right, the atomic mass. Therefore, the atomic number, it is the number of protons in an atom of an element. Okay. And then the atomic number. This is the mass of an atom. All right. Let's move on. And then we've got a lot of terms that we still need to define grade 8. Let's check the subatomic particle. When we are looking at the subatomic particle, we are looking at the particles that make up an atom. All right. And then what about the proton? This is the positively charged subatomic particle. And then when we're looking at an electron, this is the negatively charged subatomic particle. And then what about the neutrons? Neutrons, this is the part of the subatomic particle which don't have a charge. They are neutral. All right. They are neither positive nor negative. They don't have a charge. And then we find them in the nucleus of an atom. Do you get that? All right. Let's make an example here. Let's say this is our atom. This is the nucleus of an atom in the center here. Then in the nucleus of an atom, what do we find here? We've got the protons, okay? Remember, protons are positively charged, and we also have the what? The neutrons, which don't have a charge. They are neutral. Do you get that? They are neutral, they don't have a charge, but the protons are positively charged. And then we've got the energy levels, or you can say shells. All right. The first energy level holds 2 electrons. Let's say this is our first energy level. It holds 2 electrons. All right. Remember, this is the structure of a what? Of an atom. And what we are putting inside, or what we are labeling inside, these are subatomic particles. We have talked about the protons, which are positively charged, and then the neutrons, which don't have a charge, and then the electrons, they are negatively charged. And then the first energy level holds 2 electrons. And then the second energy level holds up to how many electrons? Grade 8. It holds up to 8 electrons. Therefore, let's put those 1, 2, 3, 4, 5, 6, 7, 8. All right. This is the second energy level. All right. And then these subatomic particles, they are being held down by strong forces. Do you get it? They are held down by strong forces. And then the electrons are orbiting around the nucleus. All right? Remember, the electrons are negatively charged, and then the protons are positively charged. These are unlike charges, and then unlike charges attract. Right. That's why the electrons are orbiting around, because they are being held down by the what? By the forces. Do you get that? Good. Let's move on. Grade 8. Then our question is, what is matter? Remember what matter is. Matter is anything around us that occupies space and has a mass. We call that matter. Do you get that? All right. And then all matter is made up of very small particles called what? They are called atoms. Remember, we cannot see atoms using our naked eyes, right? Because they are very small, they are tiny, they are minute. All right. And then we've got examples there. We've got the diamond, juice, and clouds. And then the arrangement of particles. If particles are closely packed, it means that is a solid. All right. And then it is held down by strong forces. Therefore, they vibrate. All right. And then the particles of a liquid, they've got spaces in between them. They can move. All right. The force is now a little bit weaker than the force in the solid. Do you get that? When the particles are closely packed and there are no spaces in between them, we call that a solid. And then they can only vibrate. And then what about a liquid? The particles are a little bit spaced out. They can move. All right? Therefore, the force is a bit weaker than the solid. All right? And then what about that one of a gas? The particles are widely spaced. All right? They are widely spaced. There are spaces in between them. They can move freely. And then the force is very weak. Do you get it? The force is weak. Okay. And then you can see the arrangement of particles on this diamond, juice, and even for clouds. Okay, we've got different particles here. All right, some are closely packed, some are spaced out. All right, and then let's move on. We have said everything that we see around us is matter. All right. It can be the uniforms that you are putting on. It can be books. It can be stationery. It can be a pen. When we're talking about stationery, we're talking about pens. We're talking about books. We're talking about pencils, crayons. All that is matter. All right. Can you give us examples of matter that you see in your classroom? Talk to your friends. Good. We've got tables and chairs. We've got the pencil case, or we've got different stationery. We also have even water. Is what? Water in a beaker is a what? Is matter. All right, because we've said matter is anything that occupies space and has a mass. Okay. And then let's go to atoms. What do you think an atom is? Remember when we defined atoms, we said an atom is the smallest building block of matter. All right. And we cannot see it using our naked eyes. Why? Because it is very small. It is minute. It is tiny. We can't see using our naked eyes. All right. Let's see here what we have. We have said atoms are the smallest particles of matter that exist on their own and cannot be broken down chemically into anything simple. Atoms can neither be created nor destroyed. And then semi-atoms are too small to see with our naked eyes. And then we've got a diagram of the basic model of an atom. All right. This is the center of an atom. This is the nucleus of an atom. What is in the nucleus of an atom? We've got the protons, which are positively charged. We also have the neutrons, which don't have a charge. They are neutral. Do you get it? And then we've got the electrons that orbit around the nucleus. They are negatively charged. Okay. I'll repeat that again. This is the structure of an atom. Do you get it? This is the structure of an atom. And then in the nucleus of an atom, that is the center of an atom, we've got the what? The neutrons that don't have a charge. They are neutral. And then we also have the protons. The protons are positively charged. Do you get it? They are in the nucleus of an atom. And they are being held down by strong forces. Do you get that? And then we also have the what? The electrons. Okay. We said the electrons are orbiting around the nucleus. Do you get it when I say orbiting? That is revolving around or rotating around. Okay? That is orbiting around the nucleus. Do you get it? Good. And then this is the first energy level, or this is the first shell. And then in the first energy level, only 2 electrons are found in the first energy level. All right. And then the second energy level, all right, this is the first energy level. We've got an electron here, another electron here. It holds up to 2 electrons. And then in the second energy level, then we are going to add another level. All right. In that level, that is the second energy level or the second shell, it can hold up to 8 electrons. All right. Good. Let's move on. And then atoms of the same element are identical. All right. We've got different elements, right? But the atoms of the same element are identical, or they are the same. For example, we've got sodium, we've got calcium, we've got gold. All right. Atoms of different elements have different masses. Okay, because these are the atoms of different what? Of different elements. Remember, an element is unique, grade 8. Do you understand it when I say unique? They are different. Do you get it? That's why they've got different atomic numbers. They've got different names. They've got different chemical names or chemical symbols, and they also have different masses. Okay. And then atoms are indivisible. All right. Atoms cannot be seen with the naked eye. All right. We cannot see atoms with a naked eye. Why? Because they are very small. They are minute. They are tiny. Okay. All atoms are made up of subatomic particles. When we're talking about subatomic particles, we are talking about the protons. Remember, the protons are positively charged, and then we find these where? Where do we find them? Grade 8. We find them in the nucleus of an atom. All right? And we also find the what? The neutrons in the nucleus of an atom. The neutrons, they are neutral, they don't have a charge. All right? That's why we are saying they are neutral. They don't have a charge. And then that is the nucleus of an atom. And then we've got electrons that orbit around the nucleus. All right? They are negatively charged. And they are being held down by forces. All right? They are being held down by forces. Why are we saying that? It is because the protons, we've said they are positively charged, and then the electrons are negatively charged. So there's some attraction there. All right? Remember, like charges attract. But unlike charges do what, grade 8? They repel. They push each other away. Do you get that? Good. Let's move on. And then let's look at the subatomic particles. All right. Let's look at the protons. Protons are found in the nucleus of an atom. When we are talking about the nucleus of an atom, for example, this is the atomic structure. Okay. And then this is the nucleus of an atom here. And what is in the nucleus of an atom? In the nucleus of an atom, we've got the neutral neutrons and protons, which are positively charged. And then we've got different energy levels, right? the first energy level holds 2 electrons. That is the first energy level, or we can say it is the first shell. Do you get it? And then the second energy level, this is the second shell. The second energy level holds up to how many electrons? Get it? 8? Good. It holds up to 8 electrons. That's great. But it goes on, it can go up to third energy level, fourth energy level, depending on the atomic number of an element. Do you get that? Depending on the atomic number of an element. For example, let's take sodium, for example. The chemical symbol is what? It is Na. And then the atomic number is what? It is 11. All right. And then how do we reach 11? This is the atomic number. Okay. Let's look at our atomic structure then. This is the nucleus of an atom. And then we've got the first energy level. I say the first energy level contains or holds 2 electrons. Now we want to do for sodium, which has the atomic number 11. And then the second shell is going to hold how many? 8. Remember, we said the second energy level holds up to 8 electrons. Therefore, we want to see how many energy levels and how many electrons we're going to get to. All right. The second one holds up to 8. Let's count 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 8 plus 2. Remember, in the first energy level, we said there are 2 electrons. Then second energy level, 8. 8 plus 2 great 8. It is 10. But sodium has got the atomic number 11. How do we get to 11? Then we are going to add another energy level. We're not going to add another shell. All right. Then we go to the third energy level. Do you get it? Remember, we said now we've got how many electrons? We've got 10. But sodium has got the atomic number 11. Therefore, we're going to add 1 on third energy level. Then it will make it 11. All right. If you are confused, let's start all over again. All right. We are looking at sodium. This is the name of the element, sodium. And then it has got the atomic number 11. And then the chemical symbol, we write Na. Do you get it? Grade 8. And then we want to see how we are going to plot this atomic structure. Remember, in the nucleus, we've got the positively charged protons and the neutral neutrons. That is the nucleus of an atom. And then the first energy level, it holds 2 electrons. Therefore, the first energy level, this is the first energy level, grade 8. It holds how many electrons? 2. This is 1, 2. But our atomic number is 11 for sodium. So we want to reach 11. And then we'll add another shell, which is the second energy level. And then the second energy level, it holds up to 8 electrons. Therefore, we're going to add 8. 1, 2, 3, 4, 5, 6, 7, 8. These are 8 electrons. And then, if we say 8 plus 2, it gives us 10. But the atomic number of sodium is 11. Therefore, what are we going to do? We're going to put or add the third energy level. All right? Then we've added the third energy level, and then we're going to add 1 electron so that it will be 11 electrons. All right. And then we get to the atomic number 11, which is for sodium. Do you get it, grade 8? Good. Let's move on. And then electrons are found in a zone near the nucleus of an atom. Remember, we said the structure of an atom, it consists of the nucleus and then the energy levels. All right. In the nucleus, we've got the what? Neutral neutrons and the positively charged protons. And then the electrons orbit around the nucleus. It is being held down by the forces. Remember, the electrons are negatively charged and then the protons are positively charged. Therefore, these are unlike charges. What do? They attract. Do you get that? And then they have a negative charge. This means when two electrons are close to each other, they do what? They repel. If you take a negatively charged electron and another negatively charged electron, if you bring them together, what's going to happen? They're going to push each other away. They're going to repel because these are like charges. And then if you bring a negatively charged electron and a positively charged proton, what's going to happen? They are unlike charges. They are going to attract. All right. These are unlike charges. They attract. All right. But if you take a proton and another proton, these are what? The protons, they are positively charged. If you bring them together, these are like charges, they will repel. Repel means what, grade 8? It means pushing each other away. All right. You take a positively charged proton, another positively charged proton, you bring them together, what's going to happen? They're going to push each other away. But if you take unlike charges, for example, negatively charged electron and a proton, you bring them together, what's going to happen? They're going to attract because they are unlike. All right. And then we have said the proton attracts the what? The electron. And then the number of electrons in an atom is equal to the number of protons of that same atom. And then neutrons are found in the nucleus of an atom. Remember, the nucleus of an atom, we said we find the what? The neutrons, which are neutral. Meaning what? Meaning they don't have a charge. All right. The number of protons is equal to the number of electrons of that same atom. And then elements are made up of atoms. You still remember what an element is, don't you? All right. An element is a material that consists of atoms of only one kind that cannot be broken into two or more substances by what? By chemical means. I love this one. An element cannot be changed into another element by means of a what? Of a chemical reaction. Do you get that? Remember when we started the lesson, we said elements are unique, right? We've got different elements on the periodic table of elements. These are unique. Do you get them? Meaning what? What does unique mean, grade 8? Unique means that they are different, right? Atoms of the same element are all identical, right? Atoms of the same element are all identical. Is that clear? All right. If we take sodium, the atoms of sodium are identical. They are the same. All right. If you take lithium, the atoms of lithium are the same. Do you get it? But one element is different from another element. Why? Because all elements are unique, but they've got the same kind of element. All right. That's it, grade 8. Let's move on. Each element on the periodic table has a what? It has a unique name. For example, we've got an element here, magnesium. This is the name of the element, magnesium. And it has got a what? A chemical symbol. Mg is the chemical symbol of what? Of magnesium. And then we've got the atomic number, which is 12. The atomic number of magnesium is what? Is 12. And then we've got the atomic mass, which is 24.305. Do you get it? Good. Let's move on. Elements are made up of atoms. Remember what elements are. Where do we find elements? We said all the known elements are on the periodic table of elements. And then we've got hydrogen, helium, and lithium. All right. These are the elements, and we find these in the periodic table of elements. And then with hydrogen, remember hydrogen has got the atomic number what? 1. Yes. This is hydrogen. This is the what? Subatomic particles of what? Of hydrogen. All right. It has got 1 proton and also 1 what? 1 electron. Okay. And then we also have helium and we also have lithium. All right. For example, let's look at the energy levels. Okay. Remember, hydrogen is in group 1. Okay. It has got only 1 shell. It has got only 1 shell. That is the energy level. And it has got 1 electron. And then remember we said in the first energy level, it holds 2 electrons. It holds up to 2 electrons. And let's look at helium. It has got 2 electrons. This is the first energy level, or you can say this is the first shell. And then we've got lithium. Lithium has got 2 energy levels. The first energy level, remember the first energy level holds up to 2 electrons. And then we've got the second energy level that will be holding 1 for lithium. But the second energy level holds up to 8 electrons. Is that clear, grade 8? Hope you're not confused. If you feel you're confused, make sure you ask us on 082 760 2630. 082 760 2630. We've got an amazing team behind the scenes who are going to answer all your questions. You can ask any question that you want. Let's move on. All right, we've already said atoms of different elements have different atomic number and even the atomic mass. Okay. And then atoms of one element differ from the atoms of all other elements. All right. Atoms of one element differ. That's why we are saying elements are unique. They are different. All right. Because the atomic structure is different. Let's look at calcium. It has got the atomic number 20 and then the atomic mass 40.08. What about carbon? Carbon has got the atomic number 6. What about the atomic mass? The atomic mass is 12.011. These are different. They are unique. Do you get it? All known elements are listed on the periodic table of elements, grade 8. All right, let's check the periodic table of elements. This is the periodic table of elements here, and it has got all the known elements. All right. And then if some elements are found, they are added on the periodic table of elements. But all the known elements are on the periodic table of elements. Do you get it? And then these are unique. The elements are unique, right? Because they've got the different atomic number and the different name and then the chemical symbol and the atomic mass. They are different. Do you get it? But the atoms of the same element are identical. They are the same. All right. Good. And then let's move on. All right. When we're talking about the periodic table of elements, this is a what? A classification system for the elements that make up the matter and materials around us or around the world. Okay. Each box in the periodic table of elements represents a what? An element. Okay. An element is a substance that cannot be broken down into two or more substances by what? By chemical means. Do you understand that? Good. Let's move on. Elements can be metals, non-metals, and semi-metals. Remember, we said in the periodic table of elements, we've got metals on the left-hand side of the periodic table of elements, and we've got non-metals on the right-hand side of the periodic table of elements. And then the region in between the metals and the non-metals, we've got the semi-metals. All right, very good. Let's move on, grade 8. And then we've got a class activity, which we are going to write just now. Okay, I'll give you 5 minutes to answer the questions. Let us start writing, but first of all, let's read the questions together. Question number 1 says, what is the smallest building block of matter? Question number 2 says, explain why not all atoms are the same. Question number 3, give labels for A, B, and C on the diagram below. And then 4, study the diagram below and answer the questions that follow. Give labels for A, B, and C. And then we are given an element, sodium, and then with the chemical name, and then the atomic number and the atomic mass. Let's start answering the questions. Handwriting grade 8, that's good. Let's check the questions and the solutions together. The question number 1 said, what is the smallest building block of matter? The answer is what? What is it? Grade 8? It's atoms. That's very good. And then question number 2, explain why not all atoms are the same. Why are atoms not the same? Atoms of different elements are different. Remember, elements are different. Therefore, the atoms of different elements are also different. They have different atomic number and also different atomic mass. And then, for example, we've got calcium that has got the atomic number 20, and then we also have carbon with the atomic number 6. And let's check the atomic mass. The atomic mass is also different. For calcium, it is 40.08. And then for carbon, it is 12.011. Okay. And then give labels of A, B, C on the diagram. Let's look at A. A is the what? Electrons. Why are we saying electrons? Because electrons are negatively charged. What about B? B, there is no charge, which means these are neutrons. They don't have a charge. They are neutral. And then what about C? The C is positively charged, which means it is the protons. Okay. All right. Make sure you mark your work, and then you take a picture and send us on 082-760-2630. Send us a picture of your work on 082-760-2630. And then start the diagram below and answer the questions that follow. These are the questions. Give the labels for A, B, and C. Let's look at A. This is the atomic number. What about B? This is the atomic name. That's a chemical symbol. And then we've got sodium, which is the name. And then we've got C, which is the atomic mass. Okay. Who got it all correct? That's good. Excellent. That's good, grade 8. But those who didn't get it correct, don't worry. Next time you're going to get it correct. Okay. And then let's summarize our lesson, grade 8. Remember what we talked about. We have talked about matter. Remember what we said about matter. We said anything that occupies space and has a mass is matter. Therefore, anything that is around us or around the world is matter. Do you get that? And then we've got what? Atoms. When we are talking about the atoms, we are talking about those particles that make up an atom. Atoms are the smallest building blocks of matter. We cannot see them with our naked eyes. They are very small, they are minute. All right. All right. The smallest particle of matter that exists on its own, which cannot be broken down chemically into anything simple, is an atom. And then a material that consists of atoms of only one kind, that is an element. All right. And then we find the elements on the periodic table of elements. All the non-elements in the world are in the periodic table of elements, but there's still room for discovery. If we discover other elements, they are added on the periodic table of elements. Do you get that? And then the other thing that you must know that the elements are unique. All right? They are unique. Why am I saying they are unique? They are different. All right, they are not the same. That's why we've got different names, we've got different atomic numbers, and different atomic mass, and even different chemical symbols. Okay. Can you tell me anything about matter? about atoms and about elements, grade 8. All right, we have said a material that consists of atoms of only one kind is what? It is an element. Do you get that? And then matter is anything around us that has got mass and occupies space. And then the atoms, these are the smallest building blocks of matter. All right. And then matter is anything that has mass and occupies space. Therefore, a pen is matter. Pencil case is matter. Your school bag is matter. The table, the chairs, all that is matter. Why are we saying it is matter? Because it occupies space and has a mass. And then all matter is made up of tiny particles called atoms. All right. And then when we are looking at atoms, these are the smallest building blocks of matter. Do you get it? They are the smallest building blocks of matter. And then we've got subatomic particles. This is the structure of an atom. When you are looking at the structure of an atom, you will find that there is a nucleus that holds the protons and the neutrons that don't have a charge together. They are held down by forces, by very strong forces. Do you get that? And then what is orbiting around the nucleus are the electrons. They are negatively charged. And then in the structure of an atom, we've got the energy levels. We've got different energy levels. For example, the first energy level holds up to 2 electrons. Okay. And then the second energy level holds up to 8 electrons. And then from the second, if we're going to the third, it depends with the atomic number of an element. Okay, it depends with the atomic number of an element. If the atomic number is 11, then the first energy level will have 2 electrons. Then the second energy level will have 8 electrons. 2 plus 8 is equal to what? Grade 8 is equal to 10. But we have said if it is 11, then the third energy level will hold 1 electron to make it 11. Do you get it? Good. And then atoms are the smallest building blocks of matter, which cannot be broken down chemically into anything simple. It cannot be broken down chemically. And then the atoms of one element are different from the atoms of other elements. What do we mean there? Remember, we said elements are unique. They are different. They are not the same. Therefore, the atoms of one element will be different from atoms of the other element because elements are unique. They are different. Where do we find the elements? We've got the elements in the periodic table of elements. Elements are around the world. They are everywhere in the world. All right. But we've got a classification system that we have, and then we've got the periodic table of elements with all the non-elements. Okay. And then an element is unique from another element. Why am I saying so? Because they've got the different atomic number, name, chemical symbol, and the atomic mass. It makes it different. It makes it unique from other elements. Do you get it? Good. And then we've got our homework activity, which I want you grade 8 to copy. All right. Question number 1 says, name the elements in each of the following substances. When you are answering these questions, grade 8, you need to have a periodic table of elements with you. Remember, at the back of our books, we've got the periodic table of elements in all our textbooks and even in your classworks. Make sure you paste the periodic table of elements at the back of your book. Do you get it? All right. The first question will be using a periodic table of elements to get the answers, to answer these questions. Name the elements in each of the following substances. We've got A, we've got Mg, we've got B, H2O, then Cl2, NO2, Ne, and O2. All right. These are the chemical symbols. You're going to come across the chemical name, and you're also going to come up with the what? With the atomic number and the atomic mass. But is H2O an element? Point to ponder. You're going to answer that. Then you'll see in your answers. Then question number 2. Write down if the following statement is true or false. If false, write the correct statement. All right. You will be given a statement. Then if it is true, you just write true. But if it is false, you write the correct one to show that you know what you are saying. A reads, all matter is made from elements. So there must be thousands of different elements. Is that true or false? Make sure you answer that one. And then B, there is no other element with atoms that are identical to ion atoms. I'll give you 2 minutes to answer, to copy the questions. I'll just give you 2 minutes to copy the questions because you're going to answer at home. And in our next lesson, you're going to bring this. All right, let's start copying the questions. 2 minutes. Have you copied all the questions, grade 8? All right, I will read through the questions very quick. Question number 1 says, name the elements in the following substances. Name the elements in each of the following substances. We've got A, B, C, D, E, and F. And then number 2, write down if the following statement is true or false. If false, write the correct statement. And then we've got A. All matter is made from elements, so there must be thousands of different elements. And then B. There is no other element with atoms that are identical to iron. Copy the homework and make sure you answer it at home. And then brief preview of the next lesson. In our next lesson, we're going to be looking at pure substances and elements. All right, we'll be looking at different substances and also elements. But remember, we've got pure substances. We'll also have what? Elements. Okay, we'll be looking at gold, copper, sugar, salt, hydrogen gas, and diamonds, among others. Okay. Thank you very much. Grade 8. Hope you have enjoyed the lesson. as we have done. Remember to always send your questions. If you've got questions, we'll answer you on 082-760-2630. Make sure you always sanitize, maintain social distance, and always wear a mask. Be kind to one another. So long for now.